Imagine moving to a new city, right? And your only goal is just to drive from your house to the grocery store.
Right, totally normal thing to do.
Exactly. In any normal scenario, you get in your car, you observe the traffic lights, you stay in your lane, and you arrive. But in this particular city, before you are legally permitted to drive to the store, the local council just hands you a 500-page technical manual
Oh, wow. Just to get groceries.
just to get groceries. You are expected to learn the exact chemical mixture of the asphalt, the proprietary taxonomy of their street signs, and like the serial numbers of the traffic light controllers.
Right.
You just wanted to pick up some milk, but you've been forced into this entire curriculum on urban engineering.
It sounds totally absurd when you frame it around driving, but that scenario, it actually maps perfectly onto how the tech industry has treated software developers for, the better part of a decade.
It really does. Welcome to the deep dive. Whether you are a platform engineer configuring the infrastructure for a massive enterprise, or just a developer wondering why shipping a simple feature feels so bureaucratic, we are unpacking a really critical shift today in how software actually gets built.
Yeah, it's a huge shift.
We are examining a really fascinating essay from August 2026. It's titled, "The Golden Path Needs an Intent Interface." And the core mission of today's deep dive is to explore the author's argument that AI agents are, well, they're fundamentally changing the interface between developers and platform engineering.
And it's about time, honestly.
Okay, let's unpack this. We need to start by establishing the baseline of where the industry is today, which really revolves around this concept of the golden path.
Right, so the golden path has been the central philosophy of platform engineering for years now. And for very good reason. Before these paths existed, development teams were essentially just bushwhacking through a wilderness every single time they needed to deploy a new service.
Like total Wild West.
Exactly. They were making ground-up decisions about infrastructure, network routing, security policies, deployment pipelines. And predictably, those decisions were wildly inconsistent.
Because everyone is just doing their own thing, which creates an unmaintainable nightmare for security teams, right?
Oh, absolute nightmare.
You end up with 100 different ways to deploy a database, and half of them are probably leaking data. So platform engineering teams stepped in to pave a road through that wilderness. They built the golden path, this curated set of templates, sensible defaults, and guardrails.
Right. And if a development team stays on that paved road, the platform essentially guarantees the service will be compliant, secure, and resilient.
Which is huge. The author of our source text is really careful to highlight that this was a massive achievement. The paved road is infinitely better than the wilderness.
It is. The critique in the essay isn't that the golden path shouldn't exist. Not at all. The critique is that the interface we use to access that paved road is fundamentally broken.
Because of how it forces you to interact with it.
Exactly. It forces developers to speak in the language of implementation rather than the language of outcomes. The author uses a highly specific phrase here, arguing that the golden path has secretly become a syllabus.
The syllabus tax. This is where the friction really lives. A developer writes their application logic, right? And then they have to navigate a platform interface that demands deep, highly platform-specific knowledge.
Yeah, it's exhausting.
They might be presented with a catalog of deployment templates that honestly all sound nearly identical. They pick one, and suddenly they are confronted with a form containing 20 or more fields.
20 fields of pure trivia.
Right. And those fields expect the developer to understand the company's internal tagging taxonomy, to know exactly which Terraform modules are required, and to fully understand the intricacies of the deployment pipeline stages.
And the cognitive load required just to deploy a piece of code is staggering.
Yeah.
If a developer doesn't already possess that specific internal platform knowledge, their momentum just completely halts.
Yep, they hit a wall.
They spend their entire afternoon reading outdated internal wikis or pinging platform engineers on Slack just to figure out, what on earth to put in field 12.
It's like spending months mastering this massive, incredibly complex filing system at your office, only to realize that when you change jobs, none of that knowledge transfers.
None of it.
A developer might spend 2 years mastering the bespoke deployment mechanisms of one company, but the moment they leave, they realize they didn't actually learn universal deployment patterns. They just memorized the idiosyncratic trivia of their previous employer's internal platform.
What's fascinating here is how the author distills this dynamic into a really sharp observation. When the expertise a platform demands is expertise about the platform itself, the organization is charging a tax and calling it a curriculum.
Woof. Charging a tax and calling it a curriculum. That is so spot on.
Right. We are taxing developers' time with implementation trivia. So the proposed solution is to shift the paradigm entirely by moving the interface up an abstraction layer.
Here's where it gets really interesting. Instead of demanding implementation details the how, the platform should only require the developer's intent, the what.
Yes.
And this is exactly the gap that AI agents are now capable of bridging. Instead of filling out a 20-field form, a developer can just state what they want.
Just natural language.
Exactly. The text gives a really concrete example. A developer just says, I need a TypeScript API, externally accessible, storing customer confidential data, deployed in 2 regions, with a 99.9% availability target.
Notice the total absence of platform trivia in that statement.
Right.
There is no mention of Terraform. There's no mention of AWS or GCP specific services.
No pipeline stages.
Right. There are no pipeline stage configurations at all. It is a pure declaration of architectural requirements. But the author emphasizes a critical nuance here. The natural language itself is not the contract.
Because natural language is messy.
Exactly. It's inherently messy and ambiguous. It is merely the input mechanism. It's how you enter the contract, not the contract itself.
So the platform takes that natural language prompt and normalizes it. It extracts all those concrete parameters, the workload type, exposure level, data classification, the availability, and it structures them into what the author calls an intent schema.
And that schema becomes the actual version contract.
Unambiguous. And once that structured intent is locked in, an AI agent takes over the heavy lifting. The agent transloads that schema into the approved platform primitives. It writes the Terraform, configures the network routing, sets up the pipeline.
The author contextualizes this shift by referencing 2 of their previous essays, which I think really helps frame the broader trajectory of the industry here.
Oh, right, the spec and the agent pieces.
Exactly. The first one, the spec is the product, establishes the idea that code is increasingly just the regenerable output of a version specification. The second, your platform has a new user. The agent points out that platforms need to cater to machine interactions just as much as human ones.
So the intent interface is basically where these 2 ideas collide.
That's it. The developer provides the specification, the agent acts as the user, generating the implementation, and the platform verifies the output.
But wait, the immediate reaction from anyone involved in infrastructure security or site reliability is usually pure panic.
Oh, absolutely.
The idea of an AI agent quietly generating Terraform and applying infrastructure changes sounds like a fast track to a catastrophic outage or a massive security breach. If an AI is writing the implementation, doesn't the platform team lose control of their own infrastructure?
It's a very fair question. But the author anticipates that exact reaction and dismantles it using a rule from another piece of their writing. Trust the gate, not the actor.
Trust the gate, not the actor.
Right. The platform's verification mechanisms, the security policies, the compliance checks, the CI/CD deployment gates, they operate completely independently of the author. A policy engine evaluating a configuration does not care if a human engineer or an AI agent generated the code.
It just checks the math.
Exactly. Its sole function is to evaluate the final artifact against the organization's constraints. If the agent generates a network configuration that exposes a confidential database to the public internet, the gate catches it.
And it fails the deployment.
Yep, fails it exactly as it would if a human had made the exact same error. The golden path hasn't been bypassed. It has simply become the compiler target. The approved templates still exist, but the developer just doesn't interact with them directly anymore.
So it actually strengthens the hand of the platform team.
Oh, undeniably. An AI agent compiling an ingent schema using a strict catalog of approved primitives is highly predictable. It operates entirely within the boundaries of the rules it's given.
Whereas a human developer...
Right, a human developer might try to hand-edit a complex Terraform file, tweaking a security group, or bypassing a standard module just to save time, hoping the reviewer doesn't notice the drift. The agent stays strictly on the paved road because it literally doesn't possess the capacity to seek shortcuts through the wilderness.
So, what does this all mean? If a platform engineering team agrees with this and wants to implement an intent interface on Monday morning, they can't just flip a switch, right?
No, definitely not.
Yeah.
It requires a fundamental restructuring. The author provides a really concrete blueprint for this transition, detailing 4 specific moves a platform team must execute.
Okay, what's move 1?
Move 1 is designing and publishing the intent schemas themselves. This is a crucial design decision because it requires drawing a very careful line between what the developer states and what the platform derives.
Okay, so if a developer states an availability target of 99.9%, the platform should automatically derive the necessary regions, replication strategies, and backup policies.
Exactly. Or if they state a specific data classification, like confidential, the platform derives the encryption standards, key management protocols, and retention rules.
So everything on the left side of that line, the stated intent, is the cognitive load you force the developer to carry. Everything on the right side, the derived implementation, is a policy the platform team now owns.
And the tension lies in finding the exact right placement for that line.
Because if you draw the line too far to the left, demanding too much input from the developer, you haven't really solved anything. You've just rebuilt the 20 field form with a slightly more modern UI.
Yeah, you've just reinvented the syllabus. But the inverse is equally dangerous. If you draw the line too far to the right, the platform begins making decisions that fundamentally belong to the developer.
Like the cost of a second region.
Exactly. A platform shouldn't automatically decide to spin up a second geographic region just because it infers a need for high availability. A second region introduces immense cost and latency implications that the developer must architect around. The developer has to explicitly own that specific intent.
Which leads to the second move, right? Once that line is drawn, the schema becomes a formal contract, which means constraints have to be machine readable.
Yes, move two. An AI agent cannot effectively compile an intent schema if your compliance rules and security constraints are buried in some PDF on a corporate intranet.
Or scattered across 5 outdated wiki pages.
Right. Context is a platform capability now. The rules governing data residency, network boundaries, all of it must be canonical, versioned, and accessible via an API. The platform must provide an environment where the agent can programmatically query the rules of the road.
That makes sense. What about move 3?
Move 3 is all about keeping the compiled result inspectable. The input is intent, the output is implementation code, and there must be a human-readable diff connecting the two.
Because the alternative is a total black box. If one intent generates 400 lines of complex Terraform, nobody's actually reviewing that.
No one.
The traditional pull request process just breaks down entirely. Teams will just start approving by scroll speed. They'll glance at this massive wall of text, assume the AI knows what it's doing, and just click approve.
And that's exactly why you don't review the generated code line by line. You review the intent itself, and more importantly, you review the delta.
The delta between the standard baseline and what's being requested.
Exactly. The platform should show the reviewer the standard implementation that the default schema produces and highlight only the specific deviations triggered by this developer's request. Focus the human judgment exactly where it's needed.
Otherwise, you've just traded the syllabus tax for a system with zero accountability.
Precisely. Which brings us to the fourth and final move, instrumenting what fails to compile. Operational maturity means accepting that not every natural language request will neatly map to your published schema.
Agents are going to fail. They'll encounter intents they can't fulfill, forcing a fallback to humans.
And the platform team must meticulously log and categorize every single one of those failures. Those fallbacks are the most valuable telemetry you have. They usually point to a gap in your intent schema, like developers are trying to express a legitimate need, but your language doesn't allow it.
Or a capability gap in the catalog itself.
Right. If your schema can't express what developers actually need to build, it is, as the author notes, just a syllabus with extra steps.
This all sounds incredibly efficient, but what about the philosophical cost? Any shift of this magnitude brings out the skeptics, especially veteran engineers. The ultimate objection is, if developers stop learning the platform, don't they stop understanding their systems entirely?
It's the classic automation anxiety.
Yeah. People worry this will de-skill the engineering workforce.
If we connect this to the bigger picture, we heard the exact same arguments when the industry moved away from racking physical servers to virtual machines, and again when we moved to the cloud. The author's rebuttal here is incredibly sharp. Memorizing which of an organization's internal templates maps to a specific microservice was never actually engineering in the first place.
Wow. Yeah, that's a crucial distinction. Platform trivia versus architectural knowledge.
Exactly. True engineering isn't knowing the precise syntax to configure an AWS load balancer. Choosing data classification, understanding the cascading failure modes of a two-region deployment, knowing what 99.9% uptime actually costs financially and architecturally, that is real engineering.
The intent interface just strips away the noise. It gets rid of field 12 of 20 and forces the developer to confront those high-level architectural decisions directly. It elevates the developer from someone just turning a specific wrench to someone actually designing the engine.
That's the vision. Platform engineering is evolving from demanding compliance through a curriculum to enabling velocity through AI assistance.
Developers state their intent, agents handle the implementation, and platforms enforce the gates. It is a vastly more efficient lifecycle.
It is. But this raises an important question. The author leaves a very subtle, really hard problem lingering at the very end of the text.
Oh, the 3 a.m. problem.
Yes. When intent compiles to implementation automatically, who actually understands the running system at 3 in the morning 2 years from now when everything fails?
That is terrifying to think about. If an AI agent generated all the intricate network routing based on a high-level intent schema 24 months ago, and now a cascading failure is taking down production, who has the mental model to debug that?
Exactly. The developer knows what they asked for, but they never wrote the underlying mechanics. The platform team knows the gates were passed, but they didn't handcraft the deployment either.
So nobody really knows how it works under the hood. The author promises to explore that in a future essay, which leaves us totally in the dark for now. But it's exactly what you should be mulling over right now the next time you abstract away a piece of your architecture.
It's the ultimate blind spot in the automation revolution.
Well, thank you so much for joining us on this deep dive. Your curiosity is what keeps these conversations going. Keep exploring, keep questioning the tools you use, and we will catch you next time as we continue navigating this wild, evolving landscape of developer workflows.